Hello, my name is Seth Holder, and this is my Physics 2 Lab 2 on charge tape. For this lab, we are going over the same thing we did in the last lab, except for we are making a computational model of the tape experiment. And instead of using it as a point charge, we are viewing it as a line of charge. So we're estimating at multiple different points rather than just a single point. This is so we can estimate the amount of charge on each tape and see how the result varies from the result we found in the previous lab. And just kind of a general analysis of the results is that the charge we got from the last lab is 1.6 times 10 to the negative 8th coulombs, and the estimated charge from the line was about double that at 3.02 times 10 to the negative 8th coulombs. The fundamental principles that we used were Newton's second law, which is the net force is equal to mass times acceleration, and Coulomb's law, which gives us how each point charge is acting on each other point charge on the other pieces of tape. The initial conditions have our system as the tape that is just acting as the bridge, and the surroundings being the tape that we were holding up to it and everything else surrounding it. The mass of the tape was about 2 times 10 to the negative 4th kilograms. The distance was about 0.035 meters, and the charge of the piece of tape we got to be about 1.63 times 10 to the negative 8th, which came from lab 1. This is the computational model that we use to solve our problem. As you can see, we put our mass as 2 times 10 to the negative 4th, and we have the force of gravity and the force of just our K constant. And as you can see, we plugged in a charge to try to balance the forces of gravity and the electrical force. And you can see that we started by looping through each point on the line of charge so that we could get a good estimate of just how much force was acting. This is the charge continued. As you can see, we had to scale down the vectors, the arrow vectors, greatly just so we could be able to see it clearly. And as you can see, we have our top tape and our bottom tape acting as two different things at two different starting positions. This is our final result of drawing the arrows and just seeing how we're adding together the charges. And as you can see in the image to the right, when we doubled the force that we got, or doubled the charge that we got from lab 1, it about canceled between the gravitational force and the electric force. And you can kind of see from all the green arrows how the charge is going up, but it's also pointing in the same amount to the right and to the left at different points. And so overall, our net force will be pointing directly in the positive y direction. Some of the sources of error and assumption that could have come from this lab are just, we're assuming that air resistance and friction are negligible, even though a piece of tape is very light and flimsy, and so air resistance might be a big issue or a bigger issue. And we're saying each piece of tape has the same amount of charge, which is uniformly distributed on the tape, but there's no way to know for sure. And because we are handling the tape, it's more than likely that the tapes do not have the same amount of charge. Errors, there could have been some inaccuracies whenever we measured the length of the tape, the width of the tape, and the separation distance. And as I said for the assumptions, there's likely some loss of charge due to handling or just having the tape in the environment. What if? What if you had modeled each of your tapes as a single point charge like in the previous lab? I talked about this a little bit earlier, but the line charge actually needed about twice the amount of charge that the point charge had just to fully cancel out the force of gravity. And I believe this is because some of the points on the line are not pointing directly up, but also canceling their values pointing to the right and pointing to the left. Why do these estimates differ? I mean, as I just explained, I believe that not all of the charge is pointing in the positive y hat direction, causing you to need more particles and just more overall charge to fully cancel out the force of gravity. And so because of that, I believe the line charge is more likely to be closer to the real value because it's more closely resembling a real piece of tape.